learning. So what is machine learning? So as you can see from that picture there's four pillars to machine learning. The very first one and often used is unsupervised learning. And unsupervised learning is essentially where you have all the data analysis and data insight. So you hear a lot about data scientists doing machine learning based implementations. And those are essentially, I'm not saying all of them, but majority of them tend to be unsupervised learning. And the idea there is that you're clustering your data into n number of to get some insight into what that data contains. So if there are any hidden trends, if there are any hidden correlations, those things come out automatically. So you just throw a set of data to the machine, and then the algorithm comes back with that insight, and then you use that to make better business decisions. The second one is supervised learning. So supervised learning mainly is about classification and regression. So here what you want to do is you want to be able to predict um, a given category or a classification based on historical data. So that prediction is you have to train the machines and based on that historical data, the machines using the algorithms you choose would learn that, and then they will be able to predict any future incoming data based on that historical fact. And then reinforced learning is again similar, that where you have more than one outcomes of a particular activity. So you know that something can be done in a variety of different ways, but which one is the best one to go with? That is where you're using reinforced learning. So you train the machine to pick the optimal under given conditions. And the idea is that the agent or the machine would take a feedback signal. So you say good, bad, or positive, negative, and it constantly learns from that feedback to then keep adapting and finding the most optimal solution, optimal option of the various options which are possible. And then last, the deep learning this is where you're using things like natural language processing, image processing, neural networks. And that's an advanced topic which perhaps we'll have to go in depth at a later date. But that's where majority of the most exciting stuff right now in terms of AI is happening. So when you talk of when you hear of things like autonomous cars or drug discoveries and things, those are all driven by deep learning. So obviously there are various terms. You might have heard about AI, RPA, machine learning. Is machine learning is same as AI and RPA? And the answer is no. So machine learning is a component of both of these technologies, and you use them in different. They're complementary or supplementary rather technologies. So you use them in different scenarios where you have humans doing a lot of activities which you want to repeat on an ongoing basis. Then you would go for the RPN approach. And with an RPA approach, you're essentially pre-recording what needs to happen. It's almost like a macro. You're at a very high level. Obviously, there's a lot more which goes into an RPA solution, but at a high level, it's almost like a macro which you're recording. And you're then going to play that again and again, and you don't need any human intervention for that. So that makes the overall efficiency of the process very high. And it's also a good tool to use for legacy applications. So you already have an application and you want to build something on top of it, and there isn't a easier way to integrate with that legacy application, then at that time you might use a tool like RPA to provide that automation. And so you're going from one application to another, doing something, coming back. So that you can almost play that back again and again with each case and provide different input and get different output out of that. Whereas the artificial intelligence and the AI part is the other way around, where you want to take the decision making out of, even if you don't want to take it out, at least you want to assist the workers or the humans taking that decision. So the machine basically is learning at that point and figuring out what is the best decision to take given a set of input data. benefit there is you get into more natural ways of engaging with systems and processes. So things like, to be able to talk to a machine, to be able to just take a picture, and then based on that get an outcome. Those are the things which you get from AI, and all of those would essentially mean using some variation of neural networks or deep learning. So there's perhaps a picture which better represents what I said just now, which is machine learning kind of fits in the middle of both of these technologies, and it complements them. And then you have this different use cases which you can then, depending on what your requirements are, decide which one is the best one to take. So how others are using is, here is an example from Facebook. So if you look at those two pictures, to actually identify what they are, it's challenging to say the least. And if we actually see the same thing, this is now comparing what a machine identifies those as compared to somebody who was actually looking at it as a human looking at it, and saying what it is. So on average you can see that the machines have got a better accuracy rate than people looking at it. And this is a real example from a Facebook marketplace, where the machines are able to identify that this is actually something which has got um, uh, contents which they don't want to publish on their marketplace, as opposed to human, where you've only got 57% accuracy, um, for this particular example. So on a wider scale, if you see, this is publicly available data from Facebook, how they are using the machine learning for doing categorization of contents. That when we place something on Facebook, obviously they have got millions and billions of contents coming through. It's not humanly possible to moderate each of those. So they're using AI to do the same. And here is an example of what kind of different things they are able to capture before it is made live, before it becomes available for people to look at. So to be able to identify fake accounts, spam, violence, drugs, firearms, these kind of things, otherwise would take millions of people to actually manually review all of these. So this is obviously Facebook has got the scale to obviously need this, but this is an example of how it can save lots and lots of machine learning and AI can save lots and lots of time and effort, and make the processes efficient. So typical use cases are into customer services, onboarding and KYC, due diligence and compliance, things like GDPR, document processing wherever there is unstructured data. It doesn't have to be just documents, things like phone calls. Ultimately, a voice call is just an MP3 file or an MP4 file. The PDFs, emails, these are all unstructured contents on which a machine learning based algorithm can actually identify what it is and then deal with those contents and extract features out of those. And then a lot of this, it's applicable in a number of sectors, but mainly things like banking, insurance, legal, and professional services that tend to have more requirements for document-driven processes and unstructured contents. So what is involved in a typical implementation of machine learning? So the first step is to actually deciding and selecting a model. So your contents, taking a basic example of, let's say, you want to categorize news articles, or you want to categorize an incoming document. The first thing you have to think about is, how are you going to represent that document? Depending on the vocabulary you're using for a particular business, you would want to take out certain words and then have more emphasis or focus on certain keywords. So you define your model in such a way that it can represent that desire for you to strip out things which are not required, and then pay certain weightage or give certain weightage to certain elements within that. Now, to do that, you then need a feature extraction routine so that you're able to extract certain things out of that document. So my point here is that the way PDF is represented is not same as how Word document would be represented. So as when it comes to when you throw those two documents to a machine learning algorithm, it doesn't know what the difference is. As far as the agent is concerned, these are just two binary contents. So you have to put something in between where in the pipeline which can actually understand a PDF structure, put something which can understand a word structure and extract relevant things out of it. So taking an example of let's say an HTML document, which will make it a bit more clearer, is an HTML document behind the scenes has got lots of tags and things. Maybe you are interested in those, maybe you're not interested in those. So in some use cases, you might say that if a word is highlighted, I want to give more weightage to that. So then your model needs to be able to cater for the tags as well. Whereas if that's not the case, if you're just reading the contents plain, then you don't care about the tags. You want to strip out all the tags and you want to get the text representation of that HTML and then work with that text representation. And then, things like if there are 5 paragraphs, you might want to separate each of those as one element to look at. So that feature extraction and that representation is very important, and that's what the first step is. Then the second thing is selecting an algorithm. So there are more, irrespective of which library you use, there's probably more than 500, 600 different algorithms which are available, or combination of algorithms which are available. I mean, actual algorithms are small, but there's, they're used in a variety of ways. And a typical implementation would always use more than one algorithm as well. You would rarely stick with only one. For obviously demos and simple use cases, yes, you can just have one, like a binary classification or a sentiment analysis. But in real world examples, you would want to use more than one of these algorithms and combine them together to achieve a representative or a good output. And in case of K2, what we're talking about here, once you have done these implementations, you want to wrap that around into some sort of a web service kind of a thing so that you can call it from your workflow. And then the output of that you will consume within the workflow which you have. So that's how you would do that integration. Obviously, ultimately, as far as K2 is concerned, this would just be a smart object. Okay, and what would sit behind that smart object is historically you could have done a class library and create your own server broker or something like that. But with K25, obviously, you want to represent that as a web service, either REST or Classic, and then consume that through a smart object on your workflow. So those are the 3 key steps. Now let's have a quick look in terms of the demo. So here I have, so just to, actually, let's go through the demo first and then I'll, so I have some demo data here. Let's say I pick up this document here, this PDF, and I'm going to drop it into this folder. So what this represents is that a letter came in an organization and that has been scanned. So once it's scanned, the output of that is a PDF file. That PDF file, the scanner utility is dropping it into this folder. So you can see that PDF got picked up. And now this has gone into, it's behind the scenes. What's happening is that that PDF gets stored into a document management system and a K2 workflow is kicked off. So that K2 workflow is deciding what type of content is present in this document, and based on that, create different tasks. So we'll see what it does with this particular one. So if I just take the standard, go to workspace and refresh the screen here, then you can see it's obviously my machine is in US time zone right now, but you can see it just created this review claim form. Okay, and I click on this review claim form, and let me actually open this in a new window. So it has picked up the policy number as P768921, Based on that policy number, it has identified who the customer is. And then here is the document which I actually dropped. So this document was dropped in Azure, as in uploaded in Azure. So it's showing that actual as a content here. And then based on that, it has also identified that this customer has these two other policies which are uh, in the system. Now, something like this would typically have taken 2 or 3 steps in a normal workflow. So you would have had to show that document for in a work list for a human to read, capture some data, so input the policy number, maybe perform some search, and then based on that search you would have then done some integration to identify all this. So the actual activities are still the same, but behind the scenes, because the system extracted the policy number out of that PDF document, it has done all of these steps automatically. So if I go back to that document, if I open this here, you'll see that that was the policy number there. So it feature extraction, and it knows how to what policy number is and how much weight is to give to this. So it has extracted that, and based on that, the workflow has essentially automated all of those steps which you would have then built the functionality for on the UI. And once you have got the policy, you know the customer, you know the other details, and then this goes straight for somebody to start working on it. And your typical steps about triaging a claim, identifying what type of document it is, all of those steps have been made redundant. Of course, in cases where it is not able to identify any of these, it would still go through those human steps. How this integration is currently done is, so we have got this REST service here. So this REST service has got a agent controller, and in that agent controller we are passing the name of the agent. So we are saying the name of the agent is essentially what we want to do. So we've got different agents to do different tasks. The agent we used here is the document classification agent. So we want to give a ID, the document ID, and we want to say, tell us what type of document this is. And then the output of that is what is being used in the workflow to then take various decisions. Obviously, here we are only talking about the supervised machine learning to do the classification. You can also similarly, if you remember in the API, there was also sentiment analysis, there's work management, there's a number of other things. But you might ask at this point, okay, so how do I create this service? You would need to code that somewhere. But before you get into doing coding and things like that, I would suggest that perhaps, if you haven't got any experience before, a good starting point would be to go to studio.azureml.net, and this is Microsoft machine learning platform. You just sign up, and it's a free workspace. And here you can have, so just to see a couple of things. So you have projects, experiments, web services. It's mainly the experiments which you're interested in that would give you a very high level understanding of what machine learning is and what are the various algorithms. Once you understand that, then you can basically take the same and just consume these from here directly. You can actually convert these into services, the models which you build here, or you can write these in your using ML.NET in your .NET class libraries and expose those through services. But writing the .NET code is not the critical part, or even the services. The critical part here is to understand what are the various machine learning options which are available, and this Azure Machine Learning Studio is a very good place to do that basic stuff. So let's look at this classification, for example. Now, all this is doing is the idea behind this particular, this is actually, by the way, a pre-built one. So when you go into this, you will see there are a lot of samples which are pre-built. So you don't have to start from scratch. You can just take one of these samples, play around with them, and sort of do a bit more learning on it. And you can always get more help from here. But what this is doing is it's taking three sets of inputs. One good thing about this is you can actually just go and visualize this. So if I want to see what data it is, then I've got I can actually take a peek into that data. So here there is this news category. What the raw data at this point, as you can read from here, it's they have stripped out common use words. So you just basically just have some keywords. Um, you could do that implementation yourself if your data is raw. So then you can implement something which would strip out any of the data. Then it takes some labels. So what are the different types of news articles um, which are available in here? So these are different categories, and there's some labels here. And then it takes some test data and use these. And there are different, and that's a good starting point. Obviously, you can spend a lot more time understanding and reading about those. But that's a good place to start. But typically, in terms of, as I said, next steps, if something like this is of interest to you, the next step I think would be to just play around with the ML Studio, and find some online training courses and things like that, and get yourself sort of familiarized with what machine learning is. Hopefully, this gives some of the use cases which are possible, and then based on that, you can take it from there.